Spring Security adds production-ready security to your Spring Boot applications, as simple as just including it as a dependency. Spring Security provides two main security mechanisms. Firstly, it provides authentication, that is verifying the identity of the user attempting to access your app, allowing or refusing them depending on your configuration. Secondly, Spring Security provides authorization, that is who is allowed to access particular resources and who is not. So for this one, we're going to set up a really basic configuration to begin with, and that's going to be using basic auth. After that, we're going to set it up to use API keys, which is typically what you'd see in the wild. Now, we're going to base this all on a project that we've already built. This is the Books REST API, which I'll leave the link to down below so you can check out the code in GitHub. It's a very basic REST API, a CRUD-style REST API, so create, read, update, and delete endpoints to manage books. We've got the project here, so the first thing that we're going to do is just do a very quick overview, and then we will get started with Spring Security. So at the moment, there is nothing Spring Security on this whatsoever. It's plain vanilla. So the first thing we're going to do is run the project, and we can do that if we zoom in here, running the following commands. We will call the Maven wrapper, and we'll say spring-boot, which is a Maven plugin, :run. So we're going to tell the application to run, and this is going to then run the application for us. We can see it starting. Everything started up fine on port 8080. Everything is good. So let's just check that to make sure it's working. So flip over to Postman here, and we'll just focus on the two endpoints. We've got one to create a book, which we go over here. Take a look at the message body. It's ISBN, which is the unique identifier of the book. Title, which is the Wind in the Willows, and then the author. And we're going to send it to this URL using a put method. So if we do that, we should get a 201 created. So click on send. And we can see here we've got a 201 created. Everything is good. Now, if we go over to the list books endpoint, which we can see here is a get HTTP verb and then this URL to list all books. Note there's no ID in the URL because we just want a list of all of the books. We will click on send, and we scroll down here. There we go. There's that one book that we created. So there's some other endpoints to this REST API, like a delete, for example, but we don't really need those to explore Spring Security. Now, notice that we were able to call a create endpoint and then the read endpoint, the list books endpoint, without any authentication whatsoever. We got the HTTP 200 straight off the bat. Now, this is a really good time to introduce Spring Security to make sure that we do have some authentication on the go. So the first thing that we're going to do is stop our application from running. So if we go back over here, go down, and then we'll Control-C out of this. Okay, and now we need to put some dependencies into our POM file. So our POM file, we're using Maven for this project, has all of the dependencies in there. We need to introduce a couple of dependencies, well, strictly one, but we'll do both of them. And one is just Spring Security, and the other one is the Spring Security test package to go along with that. So if we go ahead and introduce those now, there we go. We have both those dependencies in play now. So we have the Spring Starter Security here, which you notice there's no version for because it will pull the version from the parent POM. And if we scroll down, we have Spring Security Test, which gives access to some additional bits and pieces when we're testing Spring Security. So there are our dependencies, and they're in our POM now. So with those dependencies in play, we can actually start to use Spring Security. To do that, we're just going to start our application. So I'm going to go back down to the command line here and then run spring boot run just like before. So this will start up the application. And it started on port 8080. So if we flip back over to Postman here, let's call the same list books endpoint as we did before and click on send. But you'll notice rather than a 200 this time, we get a 401 unauthorized. So we aren't actually authenticated to hit this endpoint. Let's double check to make sure it's not a fluke by going over to the create endpoint that we called before. And let's click on send. And again, a 401 unauthorized. So just by bringing in those Spring Security dependencies, Spring Security is already kicked in and it's disallowing everything. Now, with the default configuration, it actually gives you a login page, which is great if you have a web app which has a front end that you want to log into. Not so great for a REST API. So to show you what that looks like, I'm just going to flip over to a browser. So I'm now going to hit exactly the same URL that we were hitting before to get the list of books. Remember that when we do a request in a browser like this, it typically makes a HTTP GET request in the same way that we were doing in Postman. So if we hit this URL, notice that we've got a redirect to /login, and we have a page here where you can type in a username and password. Again, fantastic for a web app. Not so great for a REST API. Now, you might be asking, where on earth am I going to get this username and password from? Well, the default configuration, the username is actually user, and the password you can see if we go back to the command line here and scroll down, there we go. We can see that we've got a line here which says using generated security password and then this password. So if we were to take this password, for example, flip back to this, then paste it in, we can see here that actually the request has worked. So we've got an empty list because we have no books created, and that's how you would do it via the browser. So this is great if you're inside of a browser, but not so great if you have a REST API. Now, there is a way that we can use this with the REST API, and that's using something called basic auth. So if we flip back over to Postman, go over to the, let's go over to the list endpoint. Now, if we go into authorization and we look for basic auth, we can see here that we have the option to add a username and password to our request. So if we were to paste in the password that we had before, in fact, show password because it's generated. So this is what it was before from the command line a moment ago. And if we now click on send, and scroll down, we have a 200 OK, and we have that list of empty books as well. So basic auth has its limitations. For one, you need to send the user and the password with every single request. Now, if your request isn't encrypted, then your password and your username is just available to anybody who wants to eavesdrop. Obviously, that's less than ideal, so there are some better alternatives. If your request is encrypted, then the risk is slightly less, but again, you don't really want to be throwing around your plain text passwords everywhere. So one of the alternatives is to use an API key. So an API key is fairly short-lived, and then you can manage that on an external system. In AWS API Gateway, for example, you can do things like rotate API keys. You can delete API keys when you like. They are far more short-lived than what a username and a particular password would be. So API keys you tend to see quite a lot. So we can set Spring Security up to now use API keys. So let's flip back over to our code and get started. If you found this useful and you want to see more content like this, be sure to subscribe. So the first thing I'm going to do is create a config file. So if I go over to the source directory in the tree up here, go into main, Java, and we don't have a directory for config, so I'm just going to create a directory for config, calling it config. And inside here, I'm going to create a new file, and I'm going to call that securityconfig.java. And that will create us a brand new class in there. Now, this is configuration, so we need to add the configuration annotation there, and that's going to tell Spring, hey, this is a configuration class. Look in this class for various configuration beans when you start up. So the first thing I'm going to do is create a user detail service. Now, a user detail service is the piece of configuration that you would use typically to tell Spring where to find the users. So users and their secrets in a lot of cases. So this could be a database. This could be an external OAuth 2 provider. You can provide any manner of custom configuration to this. Obviously, word of warning, whenever you are homebrewing your own security, unless you are a complete expert, get an expert to look over it. You don't really want a security implementation that's full of holes. So we're going to use something that you should not use in production, but it's okay today for our tutorial purposes. And that is an in-memory user detail service. So that's going to allow us to create a user in this configuration that then we can use moving forward. So let's implement that bean now. And there it is. Let me talk you through this. So we have a bean, which is the user details service here, and we can see we're creating an in-memory user details manager, and then we are creating a user on that manager. Now, also note that this is deprecated. It's deprecated because it's not safe to use in production. So that's a nice little touch there. But again, it's okay for our purposes today. So we can see we've got a nice little builder pattern, sort of liquid configuration pattern, and we're providing the username here, the password, and then the roles, which in this case is just the user role, and then we're returning the manager. So for all intents and purposes, this is going to create us a single user that we can then log in as rather than that random user. So that's typically step one whenever you're using Spring Security. So the next thing that I'm going to do is create a class to handle my API key auth. Now, this is going to be a filter class, and we'll talk a little bit about that in a moment. But for the time being, it's worth noting that you don't get the API key stuff out of the box with Spring Security, as far as I'm aware anyway. So you need to do a little bit of additional work. So I'm going to go up here to my config directory, and I'm going to create a new class, and I'm going to call this one API key auth filter.java. Just going to fill in the rest of the details, and we will talk those through. Okay, so this is a typical pattern that you see for this sort of thing. So we can see here we've got a instance variable, which we've called principal request header. And we've got a constructor, which just passed in the request header and then assigns it to the local instance variable here. And then we've got two overridden methods. We've got the get authenticated principal, which passed in the request, and then it will return an object. And then we've got the get authenticated credentials over in as well. Now this just returns null because for this purposes, we don't really need this one. All of the magic happens with this method here. So ultimately what we're doing is when the request is passed in order to get the authenticated principal, we are just getting a header from the request. The principal request header is the name of the header, and we're just returning that. So we're going to configure this in the next stage to look for the header of X API key, which tends to be the convention. So if you imagine this to be the string X API key, we're essentially taking the request and then we're getting the header X API key, and then whatever the value is for that, we're then returning it. So it's an object in this case, which is the Java top level object. We'd have to cast that later, but this is the overridden method. This is what the signature is. So that's what we'll need to do. So this is just a very basic class, which essentially extracts a particular header from a request and then just returns the value. So we'll now use this in our Spring security config. So let's flip back over to there, and I'm just going to create another bean. So let me fill that in, and then we'll talk through this. All right, here we go. So the first thing I'm going to do is the user details service we're already familiar with. So just to make things a little bit clearer, I'm going to minimize that. It's still there. It's just minimized. So let's start from the top, shall we? So we've added an annotation here, which is enable web security. This particular configuration class is going to contain the web security, believe it or not. So we need to add this annotation here. So that just tells Spring to look for web security in this particular class. Now, this is a pattern which might be unfamiliar to you, but essentially what we're doing is we have two instance variables here. We have the principal request header and the principal request value. So the principal request header is the name of the header to look for. So that is the key of the header, if you will. And the principal request value is what we're expecting the value of that header to be in order for the user to be authenticated. Now, this is a pretty basic implementation, but ultimately what we're going to do is look for the header using the name of the header in the principal request header, and then we're going to match it against the expected value of the principal request value. And if they match, then that user is authenticated. And if it doesn't match, then the user is not authenticated. So this @value annotation here is a nice, easy way to get values from your properties file or just your configuration in general, to be honest. You can see here I've got a value devtero books API key and devtero books API key value. Now you'll also notice that there is this $ and curly braces kind of wrapping them. And that's what tells the value annotation that this is something you should look up in the environment. So let me show you this over in application properties. So bear in mind, devtero books API key, and then value. There we go. So API key is the X API key header that I said about earlier. And the API key value is just a random value. So basically, if the service gets this value on the X API key header on the request, then we're going to be authenticated. If we flip back over to security config, this is just basically bringing it in from the properties file. So this is where the magic happens, and this is our filter chain. So this is where we put in the API key auth filter. This is a little bit involved, so let's go through this together. So we've got the API key auth filter. So this was our class that we created a moment ago, and we're passing in the principal request header. So that X API key string value, because that's the header we want to look up, right? After that, we're now setting the authentication manager. So this is a functional interface pattern here. So the set authentication manager, if we go into this, is expecting an authentication manager. Now this is an interface, and if we go into the interface, it only has a single method, which is authenticate, taking an authentication. So because it only has a single method on the interface, we can implement it in this way. So there's our authentication being passed in, and then this is our implementation. So we're doing get principal on there, and then we're casting it to a string because our principal is a string in this case. Then we're checking to see whether or not the API key value matches what is expected. So we can see here the principal request value is what we're using up here, and we're just doing a plain old equals for the principal. The principal is the security term for it, but essentially this is whatever the value of the header is, right? In our particular case. So we are matching the value of the header against what we expect it to be. And if it doesn't match, then we're going to throw a bad credentials exception, which Spring knows how to handle. And we're going to just pass in a message that the user did not provide a valid API key. However, in the case that it does match, then we can say is authenticated is true, and we'll just return the authentication in a roundabout sort of way. Look up the header. If the header matches the value we're expecting it to be, then authenticated. If the header doesn't exist or it has a value other than what we're expecting, the user is not authenticated. And because it's a filter, this will run on every single request. there's the concept of the filter chain. Filter chain is one filter runs, then we'll call the next one, next one, next one, next one, next one. And then you can insert your own filters into that chain, and this filter chain will run on every single request. So we just happen to have one here for our security purposes. So this next bit will be familiar for anybody that's taken a look into Spring Security before, and it's this nice builder kind of liquid configuration pattern here. So what we're saying is we're doing a stateless session creation policy, and we're adding our filter, which is our filter that we've created up here. And then we're saying any request that's sent to this app must be authenticated. You must be authenticated for any request. In summary, look for an API key. If it exists, look for the value. If the value matches, you're authenticated and everything's good. Any other case, you're not authenticated and you'll be disallowed access. So let's test this, shall we? So I'm just going to scroll down to my terminal here, and the application's still running. So let's cancel out of that and let's start it up new. Okay, and our application is started up on port 8080. You can also see that there is no randomly generated user anymore because we were specifying that user details service. So we don't have to worry about any randomly generated users. Okay, let's go. So let's flip over to Postman. Let's get rid of basic auth and then go to no auth on the request. And I'm just going to do a list. Give me all of the books. Give me all of the books that you have, expecting it to fail. There we go. We've got a 403 forbidden. You do not have access to this. You are disallowed from accessing this. That's the direct result of that exception being thrown that we configured in our Spring Security configuration. Let's go into authorization. Let's add an API key. So there's our X API key header. So bearing in mind that when we select API key from here, it will be added as a header to each request. So there we go. We've got the X API key. So this is the name of the header that we're going to send the API key on. Now, this is not the correct API key. So we need to get the correct API key from Visual Code Studio. So if we go over to the properties file, application.properties, and I'm just going to grab this randomly generated one from earlier, flick back to Postman, and I'm going to place that in that field there. Let's give this a go by clicking on send. So we have a status of 200 OK, and if we scroll down, we also have an empty list of books. All right, so let's take this one step further and let's test now the create book endpoints. If I flip over here, there's the put, there's our ISBN. Let's just double check the body, the waves, General Wolf. We're going to create this one this time around. And let's go to authorization and let's select the API key. And that is the correct value from our other request that was copied across. Nice one, Postman. So let's go ahead and send this request, shall we? But look, there is a 403 forbidden again. Why could that be? So the X API key is being provided here, and we also have definitely the correct value in play. So why are we still getting a 403 forbidden? And the reason for this is there is something else at play. So on our GET request, they were working absolutely fine. And the reason for that is when you do a request that can mutate, like a change request, like a post or a put or a delete, there is an extra step that kicks in Spring Security, and that's the CSRF step, which is the cross-site request forgery step. So this is a token that it expects to find on the request to make sure that it's actually coming from the website it expects it to, and not from a forged website or a fake website or something that's malicious in some way. So for a REST API like this, we're going to choose not to use CSRF. And the way that we do that is by changing our Spring Security configuration. So if we flip back over to the code, and we'll go down to this little builder pattern at the end here, what we're going to do is we're going to do another line in this configuration, and we're going to say .csrf disable. Just like that. And let's restart our application. Okay, application's up and running, everything's great. So let's flip back over to Postman and let's try sending that request once more, shall we? So let's click on send. There we go. This time around, we have a 201 created because we've disabled our CSRF. Let's go over to the GET request and just make sure that we can then get the list of books that we're expecting using the API key, which we click on send here. We have ourselves a 200 OK, and the list of books includes the one that we've just created. Everything is great. Now let's just make sure that that API key is definitely doing what it's supposed to be doing. So if I delete some and put in some characters, let's try sending it now to get a list of books. 403 forbidden, and the reason for it is that the API key does not match what we're expecting it to match. So That is a very basic implementation of API keys. This is obviously not the most secure implementation of API keys. It's great for a tutorial, but it's probably not the 100% what you want to be doing in production. So word of warning on this one, whenever you are homebrewing your own security implementations, always get it reviewed before going to production. So the basics of the basics is the API key that we stored in our properties file. Under no circumstances would you want to put that into source control. And in production, if you did choose to inject the API key in some way, using something like a secrets manager would be a better approach than if you were just doing that via a standard environment variable in some other config file. So that is a very basic implementation of Spring Security, and we've shown you how to use basic auth, and we've also used an API key implementation as well. As per usual, I'm going to commit this and push this on up to GitHub so you can take a look at it and review it at your leisure. And there you go, the basics on how to use Spring Security. Now, if you're interested in learning how we built that REST API, be sure to check out this tutorial here, where we build the Books REST API in Java and Spring Boot completely from scratch. I'll see you over there.